Right, let me help you with some energy, forces to and work questions and forces and their effects questions. And this is from the Combined Higher Paper 2 on Edexcel. But these questions are good for any GCSE Physics. Now I've took these questions from the last few years and you can see there's only 13 marks being asked. It's only a very small topic. Right, question 1. An athlete uses a training machine in a gym. The display on the machine shows the time spent on the machine and the amount of energy transferred during a training session. Figure 5 shows the display for 2 different sessions by the same athlete. Right, so session 1 shows you how much energy they've used and the amount of time, and then session 2 shows you the amount of energy that they have used and the amount of time. The first thing I notice is that it's the same amount of time in both sessions. Explain what the displays show about the average power of the athlete in each of these 2 sessions. So, average power. Now, as I say to my students, always base your explanation on the calculation. So the first thing you do is write down what the equation for power is. Right, power is energy transferred over time. So you can see in session 1 they've burned more energy than in session 2 and they've used that energy in the same amount of time. So if it's worth 2 marks, we'll just put that. So session 1 is more powerful because they've burnt more energy off in the same amount of time. So basically session 1, they've used more energy per second. If it was worth more than 2, you could work out the power. So that's 0.15 kilojoules per second or kilowatts. And session 2 is only 0.13 kilowatts. Remember, 1 joule per second is the same as 1 watt. I'll be honest, you'll get the 2 marks just for putting this explanation down here. If it was worth 3 marks, or if they did insist that you did it by calculation, then that's how to do it there. Question 2. A cyclist is riding a bicycle at a steady velocity of 12 metres a second. The cyclist and bicycle have a total mass of 68 kilograms. The cyclist starts to cycle again. The cyclist does 1,600 joules of useful work to travel 28 metres. Calculate the average force the cyclist exerts. Right, what they've done is they've gave you loads of bits of information to try to put you off. It's what you call an ambiguous distractor. This is why it's so important for you to know your equations. Energy transferred or work done equals force times by distance. It's gave us the distance and it's gave us the amount of energy. We just need to rearrange that to find the force. So therefore, force equals energy transferred over distance. So that's 1,600 joules divided by 28 metres. That's 57.14. And that'll be in newtons because force is in newtons. Now none of these other numbers have got decimal places, so I'm just rounding it up to 57. Question 3. Figure 14 shows an athlete using a fitness device. The athlete stretches the spring in the device by pulling the handles apart. The spring constant K of the spring is 140 newtons per metre. The athlete does 45 joules of work to extend the spring. The athlete takes 0.6 seconds of time to expand the spring. Calculate the useful power output of the athlete when stretching the spring. Right, so it's gave us a K value, it's gave us an energy value, it's gave us a time value, and we've got to work out the power. Right, the equation for power, once again, power equals energy transferred over time. So all of these questions would have came from different exam papers, so you can see they like to use this equation. So just pop the numbers in, 45 joules of energy or work divided by 0.6 seconds. And that comes out as 75 exactly. Part 2. Calculate the extension of the spring using this equation. E is energy. So a half K times by x squared. Right. If I know that I'm rearranging the equation, instead of putting the half in on the top, I prefer to say divided by 2. It just helps us to rearrange it. Right, so therefore, if I multiply both sides by 2, that'll cancel out the 2 on that side, and it'll just leave that. So I've cancelled out that 2. Now I just need to divide both sides by K. And that'll get rid of the K on the right hand side. Now I don't want x squared, I just want x, so I just need to square root both sides, and that'll get rid of the square. And there we go, just pop the numbers in. So the energy was 45. Okay, this is part 2, so obviously we still just use the numbers from part 1 as well. And the K value was 140. I always just pop the numbers, units in as well. So do 2 times by 45 first, and then divide it by 140, press equals, and then square root it. And that comes out as 0.80. And I'm just leaving it as 0.8, because the greatest number of decimal places was 1 decimal place. Question 4. Answer the question with a cross in the box. Which of these is the equation for work done? So work done equals force times by distance. So it's B. And that's why it's important to know all your calculations, because you sometimes get a nice easy mark. Question 5. Which of these forces keeps the moon moving around the earth? Come on, easy. Gravitational. And which of these is a scalar quantity? So remember, a scalar has size only, as opposed to a vector, which has size and direction. So velocity is a vector, momentum is also a vector, acceleration is a vector, so the answer is energy. And that's that. So just short and sweet. So I hope that helps. I'll be posting more help on the way up to the mocks, and then in preparation for the real exams. Right, bye for now.